Welcome to today's Explainer. We're diving right into how AI generates new images inside the Dream Factory. Today, we're literally peeling back the curtain to demystify the exact process behind those mind-blowing, photorealistic AI images we're seeing absolutely everywhere right now. We're going to break down the mechanics of how artificial intelligence actually constructs entirely new realities from scratch. Let's get right into it.
AI secret number 10. Okay, I love this hook. To really wrap our heads around the crazy architecture of neural networks, we're bringing in a conceptual guide named Neo. Think of Neo as our VIP backstage pass. He's going to take us directly into the machine's latent space, walking us through the ultimate blueprint of artificial creation so we can see exactly what happens the very millisecond a prompt is processed.
Section 1. The AI Imagination Myth. So, to really understand the machine, we first have to confront, hands down, the biggest misconception out there. Human imagination and machine generation, they are fundamentally different processes. Human cognition relies on lived experiences, emotions, episodic memory, and those spontaneous little sparks of unprompted inspiration. We daydream, right? Artificial intelligence, on the other hand, relies purely on statistical probabilities. It doesn't imagine, it generates. It pulls this off by combining literally millions of learned parameters and recognizing patterns within massive databases of training data. So while it constructs something that looks completely brand new to our eyes, mathematically speaking, it's really just a highly sophisticated synthesis of everything it's already analyzed.
Section 2. Inside the Dream Factory.
Okay, let's conceptualize this synthesis process. Picture this. You're stepping onto a glowing platform suspended in this massive, futuristic data center. Here, our guide Neo meets Nova, the operating system, who fires up this giant holographic canvas. But here's the catch. The canvas isn't blank. It's surrounded by thousands of glowing pixels just swirling around in this chaotic digital storm. This is raw, unprocessed data. It's pure digital noise, basically just waiting for a prompt to give it some kind of direction and structure.
And when Nova initiates the process, we don't just stare at the canvas. We actually dive deep inside a single one of those glowing pixels. It's like a digital universe in there. Entering this vibrant, colorful, transformative space represents diving into the high-dimensional latent space within the AI model. And inside here, every single point of light is a dense mathematical vector. They contain incredibly compressed information about shapes, textures, and context that the model learned from billions of reference images. It's wild.
Section 3. The pattern universe.
So, within this latent space, things actually start to take shape. Millions of floating fragments emerge. Eyes, mountains, clouds, animals, buildings, robots. Now, these aren't full images yet. They are isolated features. You see, during its training phase, the AI model breaks down visual data into these distinct elements. It's literally learning the exact mathematical representation of the curve of an eye, the gradient of a cloud, or the sharp geometry of a robot. And these fragments just rotate in a massive vortex around Neo, perfectly illustrating the millions of learned parameters the model has in its toolkit.
But raw data still needs synthesis. The system has to apply algorithmic synthesis, which we're representing here as this intense holographic energy, to map the relationships between these completely different fragments. Using really complex cross-attention mechanisms, it figures out how a robotic texture should mathematically align with, say, the shape of a building or a mountain. And as these parameters weave together, they hit this critical mass, merging into an absolute explosion of colorful light as the algorithm finalizes its foundational map.
Section 4. 4 Steps of Creation.
All right, now we enter the generation phase, which relies on a process you've probably heard of called diffusion. And this is where the magic happens. The artwork literally begins to assemble itself right out of the noise. Brushstrokes just paint themselves as the model iteratively denoises the data, taking those chaotic pixels and refining them into complex textures over multiple steps. You can watch as these textures anchor themselves, mathematically predicting the absolute next logical pixel until they form a highly realistic, breathtaking, futuristic city. It's just a precise, step-by-step algorithmic assembly of reality.
So, the pipeline essentially follows this strict 4-step engine of creation. Step 1 is patterns. That's extracting the core features and recognizing the isolated fragments during training. Step 2 is learning, understanding the deep mathematical and contextual relationships between those fragments. Step 3 is generation, utilizing that algorithmic synthesis and diffusion to pull those fragments out of the noise. And finally, Step 4 is the image itself, the fully rendered high-resolution output. This specific chronological sequence, that is the undeniable true engine of all modern AI image creation.
Section 5. Welcome to reality. As the diffusion process finalizes,
The generated painting expands until it is completely indistinguishable from reality, and Neo literally walks out of the artwork directly into an identical futuristic city. The latent space has become a tangible environment. But, as Nova reminds us here, quote, every AI image starts with patterns. I really want you to anchor yourself to that concept. No matter how breathtaking, emotional, or wonderfully spontaneous an AI-generated image feels, its fundamental DNA is entirely composed of repurposed data. It's the recognized patterns of the past, just synthesized into something new.
And those shimmering, glowing particles forming the Neo AI X logo fading in serve as a perfect final reminder of that foundational truth. Because every breathtaking cityscape or hyper-realistic portrait we see is really simply the ultimate resolution of those thousands of foundational data pixels. It's that chaotic storm of digital noise finally resolving into crystal clarity through pure mathematical precision.
So I want to leave you with a question to chew on today. We've explored the architecture of the latent space, right? We know the generation secret, but if every single AI image is strictly a statistical combination of past, human-learned patterns, what exactly happens when the machine runs out of new patterns to learn? When AI models are increasingly just trained on the synthetic outputs of other AI models, what happens to this whole generation process? That's something to think about the next time you analyze a piece of